Welcome back. I think I might have sorted the board issue. Just trying again. I'm going to debug mode. Okay. Still thinking. Fingers crossed. Yay! Sorry guys. I think I'm using very old laptop and some of the port pins, the USB port pins are a bit loose. That's why. Once it hits to debug, then I can show you in the special function registers this value, and then we'll proceed. It's not long to go, so just please bear with me. It's 79%. Yeah, click on switch, which is good sign. Whenever you see the switch, it makes me happy that okay. So Windows, go to Window, Show View, and SFRs. Click on SFR, and I'll show you the RCC register, RCC, AHB1ENR register. SFRs, AHB1ENR. So if you watch this register once, I'll go step by step into. So after it changes, sets its port, then you see this value change to 0 cross 6. So I go step into, I need to terminate and relaunch. Sorry, terminate and relaunch. Yeah. Okay. Sorry, it's a bit slow. It's only on 4%. Just I'll take my image off so you know what's happening in the background. So you can see it's on 4%, 51% now. So we got to wait for this to get to 100%. 79. Yeah, click on switch now. And now I need to show you the value 0 cross 6. So this time I'll go step over. Step over. Yeah. So this is what I wanted to show you, 0 cross 6. So this means both the GPIO B enable and GPIO C enable are enabled. So we set these two bits by writing 0 cross 0 6. Ta-da! Voila! Thank you. Okay, let's go into further to write the program. So the next step is you got to set the output motor. Set the output mode or register. So for GPIOB, you're going to use this for control lines, and choose the motor, and you got to simply R with this value 0 cross 5400, and then set the GPIO value, GPIOC, the data lines as well as the output we are setting. So motor, and simply R with this value 1 2 3 4. Yeah. Next step is setting GPIOC mode register as output. You're also setting the control lines as output as well, so I'll mention that there. Okay, then now we got to set the enable bit. So we are setting enable and read write as low. So this will start to get the pulse of 3 millisecond. You have to use this register, bit set register, and simply R with 0 cross 00 C value. Okay, so I'll go terminate and relaunch to check for these register values. Okay. You got to wait for this to hit to 100%, and then I will start with unsigned values. %, switch. So now if I go step over, you can see 0 cross 6 first step over. Yeah, so these values should be up in there. If we go to output register GPIOB, BSRR, output mode register. I'm going to this time just run and show you the register values. See, already the motor 3 started with 2, motor 4 started with 2. So if you click on that, you will see this 1010, motor 3 1010. So this is what we did, and go to GPIOC motor values, simply run. Okay, bits are enabled. Okay, let's now go and write function for sending command and data and a delay. So I'll copy this. Write functions for command data and generate 1 millisecond delay. So first LCD command of the argument will be unsigned character command. Okay, got to copy this. I'm going to create for data function. So LCD data and then I will write a program for the delay as well, delay millisecond. Delay underscore millisecond. Argument is int delay. Okay, so now we created, now we go and write the function. Control C, come here, Control V. Okay, first we need to set register select as 0 and rewrite as 0 because this is a command. So set the GPIO B ports, that's where the control lines are. And then set the bit set reset register value as, because we're doing both register select and read write. So read write both bits setting to 0. So this is shift 16 times. Okay, and then the output data register will receive the command. Output data register will receive command. Now we got to enable and disable the enable, set the enable. So GPIO B and set the BSSR register as EN. This EN, copy this EN, come here and paste it. Then just generate a small delay here. We got to write delay underscore ms of the delay value, just random 30. Okay, now we got to clear the enable B. BSRR enable clear times, and this is for clear enable. That's set Okay, so now we have written the program for, sorry, not the program, the function for LCD command. I'm going to copy this and going to use the same function for LCD data. We need just a couple of changes. Copied, Control V. This time it's a data. Please make sure you create the same function name, otherwise you get error in here. So now we need to set this as 1. Before this, I will, because we generated the delay there, I will write the delay program first and then we'll go to the data. Just copy that function, Control V. So first write a delay program, move into delay, int I, just a simple for loop for delay greater than 0, delay decrement, then because we're going to use 16 megahertz and we need to generate 1 millisecond, so we're going to need another for loop to generate that 1 millisecond. Equals 0, I less than 3195, y plus plus. So this is 16 megahertz to generate 1 millisecond delay. That's why we are using that. Okay, so we created the delay, just save that. Now we'll go and write the, we'll check to see if there is any error that I made. Build the project. 3 errors, LCD, command, LCD command, oh, small c, sorry, lowercase c, save. And is that the only error? LCD data command, LCD command, yeah, right click, build the project. They should clear it now. No. Oh, I didn't finish. Actually, this is not, this will be just data. Save, right click, build. Undeclared data, okay. We haven't declared data. LCD data. Data, so I'll keep it simple. Data, copy that and put it here as well, so we won't get the error. As function argument, save, right click and build the project. it will go through. Now we got to go and make a couple of changes in the data, because we got to set the register select as 1. So to do that, we need to just say rs register select. So this means rs equals 1 for data. Then we got ODR data, that is okay. We setting the enable, then delay, then we need to give further delay here because we're going to get data, so it will take sometimes. I need to have extra delay. Okay, so far so good. So I'll save that. So now you need to write it to the LCD. Now write to the LCD. Create a function LCD initialization init of, and then sorry, right, just declare Control C. You can save it here. LCD init. Okay, the first you need to say the unsigned character I. You need to start with 0 initialization. Then you're going to call the GPIO unit here. And then send all the LCD command, LCD underscore command. First one we're going to say it's a 16 by 2, so it's 0 cross 38. This is to say using 16 by 2, and then give a delay. Copy this delay, paste. So we're going to send 4 commands, write it. So I'll copy. The second will be 0 cross 0 C, setting bits. Zero C, set bit. And then we need 2 more, so copy this. Come on, please cooperate. You're learning. Okay. Next, you're going to clear zero cross 01, clear LCD, then turn the LCD on by saying 0 cross 80 will turn the LCD on. So I'll show you 38C1 and 80. If we go to the presentation, the hex codes, we're using 0x01 clear display screen, display on cursor of 0x0C, and we use 38 meaning 2 lines, and also we're using 80 which is turn on 80, force cursor to the beginning. 0C is display on, cursor off. Display on, cursor off. Okay, so I'll save this program so far. Now I'm going to check with the message, incoming messages. So I'll just put a simple while loop, while of message coming through, checking with the argument I is it equal to 0, \0, and then check with the LCD messages, LCD data of message of I. Message of I, then start to increment the I character. Okay, this should be the LCD in it, and then after the delay generation, then give further more delay because we're going to send character by character data. Wow, the ID is for some reason is very slow. Sorry. Okay, Control V, going to give 50. Okay, we nearly finished. The last step is to write the main program. So we need to call this LCD init to the main, and we'll be finished. LCD underscore init, save, and right click and build the project. It's still loading, sorry, it's taking time, it's 25% running. Still running as 31%. Please wait. Yeah, 0 errors, 0 warnings, which is a good thing. Okay, now we're going to go and debug. Right click, debug, STM32 application. It starts to connect to the debug mode. and as soon as it hits to the debugger line, at the last stage it dropped out of the debug, so you need to give right click debug again to connect to the target port. Yeah, this time it's connected through. Sometimes it lapses because it checks the initial time, and if it doesn't, if the target board is not responding, it will throw that error, and you have to go and do the right click and debug again. Still 4%. We got to wait for this to change to 100%, so it's on 51%, and it's still loading with this green progress bar. %, now 82. $89. Waiting for debugger connection. It's going to switch to debugger mode shortly. %93. Still loading. I don't know, sometimes this progress goes so fast, and sometimes it takes a long time to load, so we got to wait until this hits 100% to see the output. Verifying, still download in progress. So it's downloaded to the chip now, the program. It will soon change this to the debug mode. $97, $98, yes. So we are on debug mode. I'm going to go and run the program to see the output. So, oh, sorry, I clicked the wrong button. It's terminating, and I got to we have to relaunch it. I click debug. I wasn't patient enough to click on the run button. Instead, I clicked the button next to it. That's the relaunch button, so that's why it has to go through the cycle again. I'm so sorry, guys. 51%. %, 79%. $80, $81. I'm a counting machine now, so I'm just counting. 89 now. Waiting for debugger connection. Yeah, now click switch. So by this time, all the program must be downloaded to the chip, and once it finishes 100%, I go here and run, and we can check the output on the LCD display. Oh, there is some launch sequence error. I'll try again. Still loading with the register values. Just bear with me for a few more minutes. Once it's downloaded to the chip, we can verify. No device found on target. Sorry, I got to do it again. Debug STM32 application debug.